How will you measure the fin performance? What are the different ways to measure the fin performance? बताइए कैसे मेजर करोगे फिन परफॉर्मेंस? इधर देखिए जरा. Fin effectiveness. One important concept is fin effectiveness. Another important concept that we are going to use to measure the fin performance is thermal resistance. The another way to measure the fin performance is fin efficiency. Now, just try to understand. Fin used to increase heat transfer area, heat transfer from its surface by increasing effective surface area. Effective surface area, right? But due to area, of course, by increasing effective surface area, everybody expect that heat transfer will increase. All right. But fin itself, you know, this is the solid. So fin itself represents some resistance. So itself represents a conduction type resistance. Conduction type resistance due to its thickness, resistance to heat transfer, from original surface, जिसमें हमने एक्सटेंडेड सरफेस अटैच किया है. ओरिजिनल सरफेस, उस ओरिजिनल सरफेस को हमने क्या नाम दिया था बच्चों? ओरिजिनल सरफेस इज कॉल्ड बेयर सरफेस. नाउ एक चीज ये है, अब ये अगर कंडक्शन रेजिस्टेंस अगर हम फिन्स लगा रहे हैं तो ड्यू टू इंक्रीज इन कंडक्शन रेजिस्टेंस व्हाट विल हैपन? हीट ट्रांसफर रेट विल डिक्रीज. एंड अगर हीट ट्रांसफर एरिया बढ़ रही है तो हीट ट्रांसफर रेट विल इंक्रीज. अब इन दोनों में कौन चीजें डोमिनेट करती हैं, वो उस पर डिपेंड करेगा कि इन दोनों में से कौन सा फैक्टर डोमिनेट कर रहा है. बेस्ड ऑन दैट ओनली यू कैन से, मान लो इफेक्टिव सरफेस एरिया से वाला जो हीट ट्रांसफर रेट है वो डोमिनेट कर रहा है तो हीट ट्रांसफर इंक्रीज करेगा. अगर कंडक्शन रेजिस्टेंस डोमिनेट कर रहा है तो हीट ट्रांसफर डिक्रीज कर जाएगा. इट मीन्स यू कैन नॉट से बाय अटैचिंग द सरफेस टू द बेयर सरफेस, means attaching the fin to the bare surface, you are going to increase the heat transfer rate. You can say with confidence that you have increased the effective surface area, all right in that, but you can't say that you have increased the heat transfer as well. So for this reason, you know, there is no assurance that heat transfer rate will be increased through use of fins. Sure, there is no assurance. So this leads to above argument argument leads to no assurance, no assurance that heat transfer rate will increase, will increase by extended surfaces, means fence. So, it means how will you, it means you cannot assure that by increasing, by using fence, you can increase the heat transfer rate. And to express that, so just try to understand that Q will increase by using fin effective surface area. Moreover, if you increase A, means you are attaching more solids, so thermal resistance will increase, and so this will lead to decrease in heat transfer. So these two are the competing factor. Competing factor. So competing factors. So which one will dominate? Based on that, you can say which one will dominate. Based on that, you can say which heat transfer will increase or decrease. So increase or decrease. Now, how to quantify that? So for that purpose, we define the fin effectiveness. Fin effectiveness. It says that Q heat loss from the fin, this is the ratio of heat loss from the fin and heat from the bare surface, means when you are not attaching the fins. If heat transfer by using fin is more than the heat transfer through bare surface, then only use of fin is justified. Use of fin is justified. It will not be always the case when QF is greater than Q bare, because of two things. I told you, two competing things that I have expressed in this. Okay. So when only in the case of QF greater than Q bare, then we will use the fin. Use of fin is justified. And justified when QF from the fin is greater than Q bare surface. So this is तभी तो आप यूज करोगे. और कॉमन सेंस विल टेल यू दैट इफ क्यू फिन अगर इंक्रीज कर रहा है बेयर से, मतलब जब हम फिन नहीं लगाए हुए हैं तभी हम यूज करेंगे, अदरवाइज नहीं यूज करेंगे. क्या फायदा फिन लगाने का? So this is the ratio of these two is called the fin effectiveness, and it is represented by epsilon f. So this is the background and definition of epsilon. I have given the background to you so that you will understand. So Q fin that you have calculated in the case of very long fin and Q where. अब मुझे बताओ इन द कैसे हम लिखेंगे इसको. Now this is equal to Q fin QF, let me write it, and Q bare convection heat transfer from the bare surface क्या हो जाएगा H, and A क्रॉस सेक्शनल एरिया जहां पे हम फिन को अटैच करना चाह रहे थे, अब वहां से फिन को हटा लिए हैं, उतनी क्रॉस सेक्शनल एरिया हम रखेंगे. मींस क्रॉस सेक्शनल एरिया एट द बेस ऑफ द फिन, and at the base of the fin what is the temperature difference? बेस को B से लिख दो तो थीटा B, एक्सेस टेम्परेचर, T minus T न्यूटन्स लॉ ऑफ कूलिंग से. तो ये हो गया, ये चीजें हम लिखते हैं. So that's how you will represent the fin effectiveness. Now, what is thermal resistance concept? Next, we will move to thermal resistance concept of expressing the fin performance. So, thermal resistance concept. This will be very useful when I will deal with heat exchanger, which will use the extended surface. Okay. Suppose you have the plate heat exchanger. We will discuss later. Just listen this thing, plate heat exchanger. So we will attach the surfaces to increase the heat transfer rate. Okay. So these extended surface will play an important role in increasing the heat transfer rate and thereby performance. Now, this thermal resistance concept, how to deal with thermal resistance concept के लिए आपको क्या चीजें होती हैं, इलेक्ट्रिक रेसिस्टेंस से कंपेयर करो. सो आर आपने पढ़ा होगा वोल्टेज डिफरेंस बी एफ बी फाइनल माइनस बी आई अपॉन करंट. करंट इज द फ्लो रेट ऑफ चार्ज. सो ये बताइए मुझे, ये जो वोल्टेज है, सपोज दिस इज द इनिशियल पॉइंट एंड दिस इज द फाइनल पॉइंट. सो इलेक्ट्रिक पोटेंशियल हियर इज, electric voltage here is Vi initial point and here is Vf. Now very similar expression we must get. So for current flow in electric wire you must have the driving force of voltage Vf minus Vi. Very similar to that, what could be the driving force right here? Right here. So you must consider and here we will consider base of the fin, we have taken the temperature at constant. So T minus, and this is the surrounding fluid, surrounding moving fluid temperature. So we will take this as a driving force and divided by QF fin. Just in place of I have replaced the Q fin. Okay. So means from here what you can get, Q fin you can get is equal to T naught minus T infinity upon R. Okay, so this is the thing. Now this T naught minus T infinity is the excess temperature at the base, will be represented by theta naught and theta naught, and this will be theta naught by R. Okay, so R of what? I will distinguish it, R thermal, yes, and for the fin, RTF. Okay. Now, if I write RTF is equal to what? RTF? RTF is equal to QF Q fin. RTF is equal to, sorry, theta naught divided by Q fin. Theta naught divided by Q fin. Now I would like to write the resistance at the base itself. So what could be the resistance at the base of the fin? So RTB. So RTB theta naught to वही होगा, and at the base Q is equal to, base means Q bare, heat transfer without using fin. So what will be this? So theta naught divided by Q bare. Q bare means H. Apply the Newton's law of cooling. So A and cross sectional area where we need at the bare surface, जहाँ पे attach किया था at the fin initial point, and theta naught T minus T infinity. So देखो T in theta naught cancel हो जाएगा और आपको क्या मिलेगा? 1/H A C P. A C for cross sectional area, B for at the base of the fin. तो ये आपको थर्मल रेसिस्टेंस मिल गया. ओके, अब मुझे एक बात ये बताइए कि अभी हमने एप्सिलॉन एफ लिखा था. एप्सिलॉन एफ कहाँ पे लिखा था? यहाँ पे देखिए. एप्सिलॉन एफ इज इक्वल टू क्यू एफ अपॉन एच ए सी बी थीटा बी। तो हम यहाँ से 1/HACB के जगह पे RTB लिख सकते हैं। एप्सिलॉन एफ में 1/HC 1/HACB की जगह पे हम क्या लिख सकते हैं, RTB। So this will be equal to what we could write. I will use different color. यहाँ पे हम क्या लिख सकते हैं, जल्दी बोलो। इसके जगह पे हम क्या लिख सकते हैं, R thermal resistance at the base QF divided by theta V. So epsilon F is equal to R TV QF upon theta V. So this is the relationship between resistance concept and effectiveness. So next what you can write, next so RTF. What is RTF? Means resistance of the fin. Theta, this temperature you are taking there. So temperature difference you are taking T, and T naught minus T infinity divided by Q fin, means the product of RTF and QF is equal to T naught minus T infinity. So can you see some relation? Now in place of QF you can put this T naught minus T infinity divided by RTF, and T naught minus T infinity is what? Theta naught upon QF. From there what you can write? What you can write in place of QF is QF is equal to what? QF is equal to theta naught by RTF. Theta naught by RTF. Now put in this equation in place of QF. So what you will get? Epsilon F pin effectiveness, RTB as it is, resistance at the base, and in place of QF you can put theta naught divided by RTF and divided by theta B. Theta B means temperature at the base. I have assumed theta naught, theta B, theta naught, whatever write you write. So theta naught, since I have taken here theta naught, so you will take here to theta naught. So theta naught will cancel out, and hence you will get the effectiveness as eta fin is equal to R TV resistance at the base divided by RTF resistance to the entire fin. Now you understand the effectiveness, how much it is effective. So, bigger term will come in the denominator when you calculate the effectiveness. So RTF means resistance due to entire fin. And RTV is the only part of that, means at the base of the surface. So that's how you will calculate the you will relate the resistance with effectiveness. So what we will get the finally, epsilon F is equal to R TV upon RTF. I will put it in block. So this is the resistance concept and effectiveness concept. I have merged both two. Now, the last fin performance parameter is fin efficiency. Fin efficiency. Now, what do you mean by efficiency? Efficiency means what you have and what, this is the ratio, जो भी आपके पास है उसमें से कितना आप डिलीवर कर पाते हो. जैसे जब हम बात करते हैं कि आपके माइंड की इफिशियंसी क्या है, तो आपके पास माइंड तो बहुत है, आप डिलीवर कम कर पाते हो. ऐसे ऐसे हर व्यक्ति की इफिशियंसी होती है ना. मीन्स 100% इफिशियंट कोई चीज़ नहीं होती. एंड दिस इज द लॉ ऑफ थर्मोडायनामिक्स. ओके, सो ये नेचर में भी यूज होता है. अब मैं फिन इफिशियंसी को डिफाइन करने के लिए आपको एक बहुत ही ब्यूटीफुल एग्जांपल बताता हूँ. पहले इफिशियंसी को समझो. इफिशियंसी का मतलब होता है व्हाट यू हैव मीन्स इनपुट एंड व्हाट यू कैन डिलीवर मीन्स आउटपुट. This is the ratio of output and input. So means what you have, that's the input, and what you can actually deliver, that's the output. So what you can actually deliver in case of fin, now I am going to write the fin efficiency. Now first you have understood the concept of efficiency, that is output upon input everywhere. Now in case of fin efficiency, what term should we use in place of output? Output means what you can actually deliver. In case here in heat transfer, heat must be actually delivered. So actual heat transfer will be the output. So actual heat transfer. Actual heat transfer. Now what will be in the denominator? What you have means now what fin have? What fin have actually. Now what will fin have? Now heat. See what will fin have? What will fin have if it is very ideal, no resistance, nothing. If there is no resistance in the entire fin, you will not get any temperature, fall in temperature along the length of the fin. So what would be the base temperature of the fin? Entire fin would be at that temperature. Means the heat transfer, this is the heat transfer. See, in case of efficiency, output in place of output and input, we take the same quantity. Okay, either heat, either anything else, either work or anything. You will take the same quantity. Okay, now here also we will take in the numerator and denominator both heat. Now in the numerator what you can deliver, in case of what fin can deliver, means actual heat transferred from the fin. That is QF you are finding out. Okay, and in the denominator heat transfer in ideal case means there is no resistance in the fin extended surface, and hence there is no fall in temperature along the length of the fin. Okay, means the whatever temperature will be at the base will be of entire fin. Means heat transfer, let me write, heat transfer would be transferred heat would be heat well, let me write in another way, heat transferred if entire fin area, if entire fin area were at base temperature. We are at base temperature. Now this is the ideal case. So ideal thing will come into the denominator. Means if you are ideal and you are using if you are very much ideal, so then in the denominator, what ideally you have and what you can deliver. So output upon input. So very similar concept you will use in case of fin. What actually can be delivered means what actual heat of transfer from the fin, and in the denominator what can be what fin have ideally. Okay, so what fin have ideally means heat transfer when the fin entire fin area at base temperature. Means if entire fin area at the base temperature, what do you mean by that? Let me draw a sketch. Okay. Suppose this is the vase and its temperature is Tb, or sometime we represent T naught. In different book you will find both these representations are very common. We are taking the constant cross-sectional area of the fin. Now this have constant cross-sectional area, constant thermal conductivity, etc. Now what we are doing that earlier there is a fall in temperature throughout entire fin. Fall in temperature throughout entire fin. Means if you draw some curve, so at temperature this, and you will find fall in temperature of the fin. Now surrounding temperature, let's say something surrounding temperature would be less than that, so I am representing surrounding temperature this. Let me draw another sketch. Now this is the surrounding temperature, it must be less surrounding fluid temperature, and fin temperature that is decreasing along the length. Now we will find much temperature gradient at the base. See, much temperature gradient at the base. So base you will find much temperature gradient. Base temperature gradient is higher. Temperature gradient is higher. Now at the fin tip you will find temperature gradient is lower, so heat transfer is lower. Now if we want maximum, if we put suppose if we keep this temperature difference throughout the fin, means we have to keep the fin at the base temperature entire its length, then only this temperature gradient will be highest, and in that case the heat loss would be maximum. Heat loss would be maximum. So this ideal case that I am referring here means entire fin surface area would be at the base temperature, means this is nothing but the Q max. So what we will represent, ideally you have Q max and what you can deliver actually. So Q actual divided by Q max. This is the efficiency. Now you understand. One question came before teaching this topic, that entire base surface is entire surface is at the base surface. देखो अब यहाँ पे आ गया, मैंने उस क्वेश्चन को एक्सप्लेन किया. आप पूरा लेक्चर सुनो, आपकी सारे डाउट्स दूर होंगे, कोई भी डाउट जो है वो रह नहीं जाएगा. So that's how we define the efficiency. Now let's take a now for so what we have defined efficiency. How will represent efficiency? Eta F, effectiveness with epsilon, and eta by eta we will represent the efficiency. Now this efficiency eta F is equal to QF, Q fin actual जो transfer हो रहा है. Actual means nothing but the Q fin. Okay, Q fin is equal to divided by Q max. So Q fin upon Q max. Now let's see in the case first. Case first में Q fin क्या आया था बताइए? Q fin क्या आया था बेटा? H P K A थीटा नॉट. देख लो आप क्या आया था. ये देखिए, दिस एक्सप्रेशन यू गेट इन केस ऑफ very long fin. So QF, put this value QF right here. So efficiency for very long fin. So for case one, very long fin. So once you have the QF, means once you have the theta temperature profile, theta excess temperature equation, then you will be able to get the QF, means heat transfer from the fin, and once you have the Q fin, you will be able to get the efficiency as well. Now let's put the values that we got earlier. So eta F is equal to Q fin, just put very politely. So H P K A theta naught outside this square root divided by Q max, and Q max I told you, just uh, remember this is the environment temperature, environment fluid temperature, and this is the temperature in the fin, this is decreasing. So I told you, if this is the base temperature, if I put now here the temperature at the base temperature difference is maximum, means temperature gradient is maximum, elsewhere it is decreasing in this direction. So if we take entire fin at the base temperature, then heat transfer will be maximum, because temperature difference, maximum temperature difference we are taking everywhere, and that maximum temperature difference exists at the base. So means how will you get the Q max? Means fin temperature कितना हो गया, base temperature हो गया. Base temperature means we are taking theta naught. So how will you get theta naught? Means T naught minus T infinity. Now put it right here. What is the equation for Q max? So maximum H and area, heat transfer area. So P, and length of the fin is, if L, then the area is PL. Surface area is PL. Surface area is PL. And T naught minus T infinity, that is theta naught, because at the base temperature, if entire fin is at the base temperature, entire fin is at base temperature, then only you will get the maximum heat transfer or ideal heat transfer. So theta naught will cancel out. So let me write it further. So HP, so 1 upon L I will write. Now this HP, if you see, I will write in square root form, then square root of H square P square, that will lead to HP only. So we can write HPK, okay, and write this also. So H square and P square, we can write it as, or HP का whole square. तो ये मिल जाएगा. अब आप लिख लो इसे, तो क्या आ जाएगा बच्चों? This will lead to 1 upon L, 1 upon L and square root of HP Ka and HP square. This square will cancel out. So what you will get next? Next you will get square root of 1 upon L square root of K by HP. K by HP. अब बताओ HP by K क्या होता है? M स्क्वायर. तो K by HP क्या होगा? 1 upon M square. So put it that there. So what you will get? Efficiency, sorry, eta F is equal to 1 upon L and 1 upon M square root, and you will get 1 upon ML. So efficiency eta F is equal to 1 upon ML. इसके बाद आप लोगों की कोई कंफ्यूजन नहीं रह जाएगी परफॉर्मेंस में, फिन के परफॉर्मेंस में. सो दिस इज 1 upon ML. ठीक है, अब हम ये इफिशियंसी है, सॉरी, तो ईटा एफ लिखेंगे हम, ईटा एफ। सो वी गॉट ईटा एफ इज इक्वल टू दिस मच। अच्छा, इफेक्टिवनेस देखो, अब हम इफेक्टिवनेस भी निकाल देते हैं इस केस के लिए। सो इफेक्टिवनेस कैसे डिफाइन होता है, क्यू एफ क्यू फिन अपॉन क्यू बेयर सरफेस। तो क्यू फिन कितना था इसमें, वो लिखो रूट एच पी के थीटा नॉट, एंड क्यू बेयर सरफेस से कितना, एच पी पेरीमीटर, एच ए सॉरी, ए विल राइट, otherwise you will write PL, but L, we are calculating at the bare surface, so QA, HA and theta naught, T minus T naught from Newton's law of cooling. Now this theta naught will cancel out, and you will be getting this effectiveness is equal to H P K, and if you will take inside square root, so then HA ka whole square will be there, HA ka whole square. So this HA, 1 HA will cancel out, this means KP by HA. So you will be getting effectiveness eta F is equal to a square root of KP by HA, KP by HA। अब यहां से कुछ हम इंपॉर्टेंट चीजें निकालेंगे, देखना कैसे। यहां से क्या पता चला, इफेक्टिवनेस किसके प्रोपोर्शनल होता है, कंडक्टिविटी के प्रोपोर्शनल होता है। इनफैक्ट स्क्वायर रूट ऑफ के, बट रफली चलो, but if you increase the value of k, square root of k will also increase, okay, and it is also proportional to square root of p by a, but if you increase the value of p by a, its square root also increase. So we will further write this is also proportional to k, this is also proportional to p by a. Now, and now h, so this is h is coming in the denominator, so it will be inversely proportional to square root of h. Now if you increase the value of h, now then if you whatever happens, so this is also proportional to 1 upon h. Now see इफेक्टिवनेस, अब मैं आंसर कर रहा हूं कि कैसे देखो डील करते हैं। अब देखो बेटा, इसका मतलब क्या हुआ, यहाँ पे जो हम फर्स्ट प्रोपोर्शनलिटी, आई विल यूज डिफरेंट कलर राइट नाउ। तो देखो यहाँ पे हम P by A लिए, P by A मीन्स ज्योमेट्री ऑफ द फिल्म, शेप एंड साइज, पेरीमीटर और एरिया कैसे डिपेंड करता है। इसका मतलब क्या हुआ, इफेक्टिवनेस अगर इंक्रीज करनी तो इफेक्टिवनेस इज प्रोपोर्शनल टू व्हाट, P by A, means you need, if you want to increase this effectiveness, then you will have to increase the perimeter and you will have to decrease the cross sectional area. Decreasing cross sectional area means thin fins, right? And increasing perimeter, you can understand thin fins, closely spaced thin fins will have the more effectiveness. Okay, next I am going to deal with this is, you have seen what epsilon f, effectiveness is proportional to, effectiveness of the fin is proportional to 1 by h. What does it mean? Let me tell you that if you increase h, it means effectiveness will decrease, and if you decrease h, effectiveness will increase. So if you want more performance, means more effectiveness, then you will have to use fins at the lower h side. So use fin at lower h side, Now you will understand, I told you that gas heat transfer coefficient of gas is less than heat transfer of liquid. So if you want to transfer heat between gas and liquid, you will use the fin on which side? Gas side. So fin is used in gas side. Now again, if फ्री कन्वेक्शन फोर्स कन्वेक्शन में किसका एच कम होता है, उधर यूज करेंगे. तो देखो एच फ्री कन्वेक्शन कम होता है, फ्री कन्वेक्शन में एच कम होता है. आई विल टेल यू लेटर. एंड फोर्स्ड कन्वेक्शन में एच ज्यादा होता है. तो फ्री कन्वेक्शन में हम यूज करते हैं, फ्री कन्वेक्शन मीन्स नेचुरल कन्वेक्शन. सो फिन इज used also in case of natural convection. Fin is used in case of pre-convection or natural convection. Pre-convection or natural convection. Now, this will explain in